I said the last video, possibly the most tricky part. Actually, I think this is possibly the most tricky part. Until the next video, when that will be possibly the most tricky part. Alright, hello again. It's time for task 3. If you used the solution video for the last one, you'll realise that in it I said, we'll do the bricks next. No, we're not going to do the bricks next. The bricks are coming up hopefully in the next video. What we need to do is we need to make it so that when the ball hits the paddle, the ball goes off in a very specific direction. And we're going to get the physics of this right. I'm going to get the physics of it wrong, first of all, to prove a point about why I need to get the physics of it right. And then getting the physics of it right is, I said the last video, possibly the most tricky part. Actually, I think this is possibly the most tricky part. Until the next video, when that will be possibly the most tricky part. So, let's deal with this. Right, now, let's do this wrong, first of all. So I want to say, if the ball touches the paddle, then, go off in a different direction. Now, I'm going to leave, do you know what I'm going to do? I'm going to leave this grid on here. I think it's really useful to have it. So here we go. Let's get this deliberately wrong. I need an if command, and I want to say, if I'm on the ball, by the way, here, if I am touching paddle. So if I'm touching the paddle, that's a sensing kind of thing, and in there you'll find if I'm touching mouse pointer, which is no good, but if we change that to paddle, and that's why it's important to have names, not sprite 1, sprite 2, sprite 3. If I'm touching the paddle, I'm going to do this bit. Then I'm going to choose this option, which is point in direction, and point in direction. And what I'm going to do to make it sort of, let me just perhaps interact here. If the ball comes down here, I want it to go off like that. Okay? If it comes down, it's going to ricochet off. In the same way, if I run this knee, sort of down, see how it ricochets off the edges here, and it'll ricochet for the bottom. I want the same thing to happen, it'll ricochet off the paddle. This is not going to work first. Well, it will work, but you'll realise very shortly that it will make a terrible game. So, point in direction. And the solution to this is to say, I need a -1 here, and I'm going to choose in here 180 minus the direction the ball was travelling in. Now you're probably thinking, how do you know what direction the ball was travelling in? Well, when we go back to sensing, you'll find that actually we've got a number of options in here, and one of them is not here, because I'm the wrong one. I meant motion, of course. And what we find here is the direction. That was very embarrassing. It's like I don't know what I'm doing.
5 hours later.
180 minus direction. This direction thing here, we're on the ball, so it's picking the direction the ball is travelling in. So I'm going to put that in there, and I'm going to put that in there. And then I'm going to put that inside the forever loop. So now the ball is either going to move forwards 5, oh, by the way, I made it 5 just to slow it down a bit, if I'm on the edge bounce. But now it says, if I touch the paddle, point in direction, 180 minus direction. Now, to show you it works, let's do this. Oh, I should have made it 10. Look, no, at least I can do this. Bam, look at that. Now what I'm going to do is watch this. I'm deliberately going to hit it on the right side of the paddle. Do you see what happened there? Ball physics. This isn't right. Let's catch. Oh, hold on, that's certainly not right. We'll come back. That's for later in the game. I'm going to try and catch it right in the middle of the paddle. And I did. And what you're beginning to realise is that it doesn't matter where you hit it on the paddle. It's going off in the same direction. Now, to illustrate this even better, let's hope the ball goes straight up. I'm going to press. There we go. That's quite a good one. I'm going to catch it right on the edge of the right paddle. And then I'm going to catch it right on the edge of the left paddle. And then I'm going to catch it right in the middle. And what you're finding is that it doesn't matter where it hits the paddle. It's just going to keep going off in the direction that it's doing when it ricochets off anything. And that is not good game physics. What we want, if I stop this for a moment and move this over here, is that when the ball hits the paddle, if it hits the middle of the paddle, it should go straight up. If it hits the right-hand side of the paddle, it should go off that way. And if it hits the left-hand side of the paddle, it should go off that way. Because my game as it is, if I start the game, if I'm that is actually pretty lucky. But if the ball chose direction randomly at 0 and went up that line here, it would never move from that line. It would just keep going up and down forever. Because the paddle doesn't control which direction the ball goes in. So we do need to change that. Now, how do we do that? Now, we're going to have a look at doing this slightly differently. So this involves a little bit of thinking. Let's try and get this into a bit of space here. Now, when that ball touches that paddle, let's say let's start on the right. When this ball touches that paddle, when that happens, we're able to detect, because the computer is sensing, we're able to detect the X position of the paddle, and we're able to detect the X position of the ball. Now, if the paddle, let's move the paddle, it's right in the middle there. So let's say, I'm trying to get right in the middle, let's pretend it's right in the middle. Actually, that's not too bad. At that point, what is the X position of the paddle? And the answer is 0. If the ball hits it there, we know the X position of the ball is greater than the X position of the paddle. In this particular case, I guess maybe that's around about 30. If it hits it here, the X position of the ball is less than, it's about minus 30. So what we really want to do is say to the computer, I want the computer to say, look, I want you to point in the direction of the X position of the ball minus the X position of the paddle. Now we're already on the ball, so we've got an X position of the ball, but we don't have the X position of the paddle. So where do we get that from? Well, the answer is it's not in motion, because the motion bit here, this is all about the ball. We're trying to find out, well, what's the X position of the paddle? And you can get it. And it's a little bit cheeky because on Scratch 2 it was a bit easier to find. But in sensing here, we're able to, where is it? I forget now. In sensing, I think it might be this one. If I change this to paddle, you'll notice here that we can do the X position, the Y position, direction, all sorts of different things. But that's the one I want, the X position of the paddle. Now here's another thing. You might find that when you're playing it, depending on the size of your paddle and your ball, you might find that when your ball hits the right-hand side of your paddle, it might only be like 20 greater, which means that if it's going to go off in the direction of 20, it's going to go like that. Now maybe you want to say, well, if you get it right on the edge, you want to go like that. So how can we do that? And the answer is we need a multiplier. So we need to go to operators, and this one here with the star, a bit difficult to see, it's a star. That's a star, that's a multiplier. So if you want to do 4 times something, you put a 4 in there, and then you can put that bit inside there, and then you can put other bits inside that, and then you can put all of that inside that, and then you can put that into... It's quite tricky, isn't it? See if you can work it out. If you can't, obviously there's another video to follow in a moment, isn't there?